Our lesson today is Introduction to Compound Inequalities. Here are a few things we want to be able to say by the end of this lesson. I understand what compound inequalities are. I can write an intersection inequality, and I can write a union inequality. Okay, so let's take a look at our vocabulary. What is a compound inequality? Well, an inequality is a mathematical sentence that compares two expressions using symbols such as the less than statement, which is this right here, the greater than statement, which is this right here, the less than or equal to statement, or the greater than or equal to statement. We've kind of been over these already in a previous video. Now, the compound inequality is two simple inequalities joined by the word or, which I know it's kind of weird because we have the word or there. So it's or the word and. Okay, so the intersection, which is known as the and statement, is a compound inequality that is true only when both inequalities that we're looking at are true. Okay, this represents where the graphs of the two inequalities overlap each other. Next, we have a union, which is an or statement. Okay, that is a compound inequality that is true if one of the inequalities is true. So they don't both have to be true, only one of them has to be true. So it's a compound inequality that is true if one of the inequalities is true. This represents the combination of both graphs. Okay, so we're putting both graphs, we're putting them on the same line, and only one of them has to be true in order for the entire statement to be true. So let's look closer at a compound inequality with the and statement. This is an intersection. And compound inequalities can be written in two different ways. First off, you can have it separated by the word and. So x is greater than -2 and x is less than or equal to 3. However, the one we're going to use more than anything else is the combining them into a single expression. So we're going to say -2 is less than x, which is less than or equal to 3. So like we said, red is x. X is between -2 and 3 is another way you can read that. Okay, so basically it's the overlap. It's like in the Venn diagram, it's the stuff here in the middle. Okay, that's the intersection. It's got to be it's got to be greater than -2, and it's got to be less than or equal to 3. So it's going to be somewhere between, between those two numbers. Okay, here are some keywords or phrases. For example, it'll say between -2 and 3. Or it could say inclusive, means it's going to include the endpoints. We could say no less than A and no more than B. We could say at least A, but at most B. Kind of gives you a range of where you could have your number between two different endpoints. Okay, so those are some keywords that you'll want to remember. Our assignment's going to kind of look like identifying keywords, so make sure you know what those mean. Okay, next, a real world example would be a student discount is available for children who are at least 5 years old, but no more than 12. So you have to be somewhere in between that. But in this case, it's inclusive because it says at least 5. That means 5 or more, but no more than 12, which means 12 or less. So we'd write it as written here: 5 is less than or equal to x is less than or equal to 12. So you have to be between 5 and 12 to be able to get that discount. All right, so let's look at the or inequalities. An or compound inequality is always written with the word or separating the two inequalities. It can never be combined into one single expression. It's always written as two. So x is less than -1 or x is greater than or equal to 3. So it's either going to be from this circle or this expression or this expression. It only has to be true for one of those expressions. So can you think of a number that's less than -1 or greater than or equal to 3? Yeah, you could say 4, 5, 6, any number bigger than that, or any number smaller than -1, so like a -2 or -3 or -4. All of those would be solutions to this compound inequality. Okay, it only has to be one of them. It doesn't have to be both. So keywords for compound or inequalities: less than A or more than B, excluding, okay, outside of two different numbers, or you could say either x is less than -1 or x is greater than or equal to 3. Okay, so using the either or would be another keyword that you want to look at when doing this assignment. Okay, so another real world example. To qualify for a special promotion, a customer's age must be under 18 years or over 65 years. So X has to be less than 18. You got to be younger than 18 or greater than 65. So there's another way you could use a or compound inequality inside of this. So let's go ahead and take a look at our last slide. So I understand what compound inequalities are. Those are our and statements or the or statements. We can write the inequalities. Hopefully, you know, for the and, we would say, if we're between like 4 and 7, we would say 4 is less than x is less than 7. Or a union would be, you have to be less than 18 to get a discount, or you have to be bigger than 65 to be to get a discount. So those are our different types of compound inequalities. Go ahead and take a look at our assignment afterwards and let me know if you have any questions.